off with the STL of priority queue, correct? Okay, so how to declare priority queue? It's always included into the library of bit standard C++.h. You can just write priority queue and let the integers kind of values I'm gonna keep inside that and let the name be PQ. Fine, we declared it. And if I declare it like this, by default, it's a max heap for you. Okay, it's gonna behave as a max heap for you. All fine. How I am gonna be putting the elements inside the priority queue? How would you insert the element within the priority queue? Let me know. So we have the push operation for that, right? Let me just say that pq.push1. Then I would be saying pq.push2. Correct? Then you say that pq.push. The operation error here. Yeah. 4. Then I would say pq.push again a 5 and afterwards pq.push again a 1. Correct? So this is a max heap for you, right? This is a max heap. How the so see entirely the structure is maintained internally. You have to just push and internally they are gonna be heapifying it. You don't require to do it because this is an STL standard template library container for me, right? I have to just keep pushing the elements here. Internally they are gonna heapify, and as per the current push operation, the top of the heap, the top element of the heap would be the largest element as per the max heap as per the max heap properties. Okay, whatever would be the top element or the top node of the given max heap maintained in terms of the priority queue, that would be the largest element. Internally, how the arrangement further is, you are not required to bother about it. Let it be anyhow that's arranged. Internally, that's going to be maintained. The topmost node would be the largest one always. How I'm going to be accessing it? Can anyone let me know how you would access? Okay, let's see whether I am current into my assumptions or not, right? So I have to say that while not pq.empty till the time my pq is not empty, I would keep on popping the elements. From where do the pop operation takes place? From the top. Whatever is the topmost node of your priority queue, that's the max heap so far we are considering, right? If you perform the pop operation, the topmost root node would be popped out. What would be the topmost root node? The maximum value, correct? So I would just say that cout pq dot what? pq dot what should I be printing? It should be the top. Okay, it should be the top, and you can just say pq dot pop it out. Okay, whatever is the topmost node, you access it. Now you just pop it. That's it. Try running it. Let's see what the result is coming. Okay, I'm sorry for this. Is it coming? First, the topmost node 5 would be popped out, then 4, then 2, then 1, then 1. The order is correct for all of us? The order is correct for all of us? Any doubts? Any doubts? And okay, if you try to convert this priority queue to a min heap, what we are required to do? Anyone? You convert that to a min heap, how I should be doing it? Any ideas onto this? You people are having any Google searches you have done so far? So see, internally, if you wish to maintain a min heap, right? Somehow the internal structure gets stored within a vector. So that's what I have to pass. You may try storing in one of the containers vector for the min heap structuring part, correct? And you have to mention that, okay, mention the particular function greater integer. Okay, greater integer. If you are storing long values, you have to mention long instead of integers. If you are storing some custom values, custom data types, you have to mention them in terms of rather than integers here, right? So two things for conversion to min heap. One is some container extra, what's gonna be holding the arranged values in terms of min heap. What is it? So I have passed on a vector here. Other kind of containers as well can be passed on. But in most of our cases, vectors are sufficient. So no need to do anything else. And I have to mention a particular function greater. That's the particular syntax I need to follow to convert the entire heap to a min heap. Okay. Min heap. So that's it. And now you perform the same operations again, right? Let's see what the result we are getting. Q dot push, haven't we initialized it? Okay, I'm sorry, we haven't given the second column. So if this is the min heap, first the lowest value, then again the lowest value, then 2, 4, and 5. This is how inside in this particular order, the overall value would be coming out. Is it clear how to declare min and max heaps? In terms of STL, how to declare min and max heaps? Is this clear for everyone?
Yes.
Okay, so unless and until somebody has asked you for interviews, implement a max heap and implement a min heap, perform heap sort. For the online assessment part, I can straight away utilize this priority queue container. Works? Okay. In any of the OAs you are giving, correct, straight away utilize. Whenever you see that a question related to that of heap utilization, priority queue utilization is coming, straight away utilize this container, the STL counterpart. Okay. No need to do anything else. No need to do anything else. All fine. All fine.
Yes.
Okay. So let's see, by the way, how we can try applying this to solve a few problems. Okay, then. Kth largest element in an array. Let me know how would you approach this problem? Kth largest element. How would you approach this?
So normally.
Yeah, anyhow, let me say that without sorting, I have to solve it. Then what I can try doing it.
Sir, hash map use করতে পারি ওর মধ্যে।
Yeah, definitely.
তারপরে
Hashtag BST. BST can also be utilized, right? You can
Yes.
store that inside a BST, you can access the elements. In terms of priority queue, if I ask you to think what answer you are going to give me, let this be the array and second largest number you are required to print. And let me take this array, by the way, the larger. Let me just take the array, by the way. What is here? They have given me 3, 2, 3, 1, 2, 4, 3, 2, 3, 1, 2, 4, and then what? 3, 2, 3, 1, 2, 4, 5, 5, 6. Okay, this is the array that they have given. Fourth largest number you have to print. What's the fourth largest number? So how to trace it? So intuitively, if I sort the array 1, 2, 4, sorry, 1, 2, 2, 3, 3, right? 1, 2, 2, 3, 3, then afterwards 4, 5, 5, and 6. This is the sorted version. If you try accessing the fourth largest value, I feel this 3 should be the answer. Is it that? Okay, sorry. So they have given that maybe the, are they considering, note that kth largest in the sorted order, not the kth distinct element. Okay, not the kth distinct element is required, but the kth largest number in sorted order. Let's just see that k is equal to 1. Why are not? Why are not they considering it? Isn't it the fourth largest number for us? But they are still giving the fourth number.
kth largest মানে 6 থেকে বলছে না, মানে যদি আমি 6 থেকে 1 2 3 পড়ি তাহলে তো 4 ই হচ্ছে।
Okay, kth largest, right? Yeah, yeah, true, true. We are just considering the kth. We consider the kth smallest. We consider the kth smallest. That's a mistake that I did. Kth largest is the fourth number after sorting it. So that's gonna be my answer. 4 would be the answer correctly. Now, if I ask you how you may try approaching the problem, tell me. How would you try approaching this problem? You are not allowed to sort, suppose. You can sort and do the problem one way. But if I sort in one of the most efficient approaches, it takes me n log n time, if I'm not wrong, right? N log. That's going to be the complexity. Sort it, access the k minus first from the end. It's not exactly k minus 1, I feel. Whatever is the largest element I'm having from the end, access that and print it. One of the ways this. Any other way that I may try doing? What are your thoughts? Any other way? Kth largest. Kth largest I'm required to perform. Kth largest. Okay, I ask you, I'm giving you a hint. Why not you perform? Why not you utilize a min heap, not the max heap? Why don't you utilize a min heap? Min heap of size k, suppose I'm giving you. Fourth largest is required. So I would just maintain a min heap of size k, not more than that. Getting it? Min heap of size k, I would be maintaining. So what should I do? Let me say that this is the container of min heap that I am trying to proceed ahead with. This would hold no more than k elements, right? This would hold no more than k elements. Not more than k elements should be here. And then I would be able to take a call. What's the kth largest element? Min heap this is. Min heap this is. Correct. Min heap this is. No more than k elements it's gonna consider. And suppose that inside this min heap, k largest elements of the array I am gonna keep. K largest elements. This is of size 4. So all the first 4 largest elements of the array would be contained within the min heap that I am maintaining. Getting it? Let's start off. Initially, the size is not equal to that of k. Size is 0, right? Size is 0. So for the first 4 elements, just safely put them into the min heap. 3, 3, 2, 1. All are put inside the min heap. All fine. First 4 elements, till the time the min heap has not been filled fully, just put all the elements together to the min heap. Till the 4 elements, first 4 elements, no problem. Just insert that. Keep on pushing them into the priority queue, whatever we are maintaining. Then 2 is coming into the picture. Then 2 is coming into the picture. The entire min heap that I have maintained should contain k overall, k largest elements of the given array. Whatever are the top 4 largest elements of the given array as per the value of k, that should be maintained within the min heap. Now let me know this 2 has arrived and this is a min heap. Can I just say whatever is kept at the top of the min heap, this is smaller than the current value. Should I remove this one? Should I remove this one? Top 4 largest values so far, whatever I have explored, that would be kept inside the min heap. Whatever is the current element 2, right? The current element, this is greater than the overall minimum of the min heap. Overall minimum of the min heap. 1 is the minimum one, that's the top root. Largest 4 values should be residing. So I should pop it and insert 2 instead. Pop the value 1, only 4 elements needs to be kept into the min heap. Beyond this, I won't be keeping. That's my intuition. So I say that if I wish to keep the largest 4 elements, current minimum is smaller than the value that is coming, that I am exploring right now. So let me remove the min heap, the root of the min heap, whatever is the minimum so far, and keep whatever is the element that's coming. Let's insert that. Let's insert that. So largest 4 elements are getting maintained within the min heap. Is it coming? So far, in the first 5 values, whatever I've explored, right, the top 4 elements, what are largest in nature, they are getting maintained within the min heap. Is it happening? Is it happening? Then let's come to the picture of 4. Okay, what's the root of the min heap? Any of the 2 can be the root. Any of the 2's, because they are the smallest. Min heap it is. K largest values I'm gonna keep. Whatever is the current value for me, this is greater than the root of the min heap so far. So I would just remove this, put 4 inside the min heap. Put 4 inside the min. Nothing else I'm gonna do. Correct? So so far, the topmost 4 values, the largest 4 values into the min heap is getting maintained. Correct? Explore the next element 5. Whatever is the root is smaller than the overall value that I'm exploring right now. So if I wish to keep the topmost 4 values that are largest in nature, root has no place into that. A greater value I have explored, that should be replacing the roots into the min heap. 5 goes inside, 2 gets popped out. So far again, the largest 4 values of the overall array, I am able to explore. Is it? I am able to explore. Is it? They are all contained within the min heap. Correct? Okay, fine. Let's go to the next 5. Whatever is the root, either of the 3's would be the root. Internal, they would arrange. I don't require to bother about it. They would arrange internally, whatever they wish. Okay. This 3 would be popped out. Now again, another 5 would be pushed into the min heap. And then the last value is 6 for us, right? The last value is 6. This 3 would be knocked out and 6 would be put into the min heap. Finally, after exploring all the values, what is happening? After exploring all the values, what is happening, by the way? Tell. After exploring all
4,
the
5,
values,
5, 6.
what are the contents? 4, 5, 5, 6. And can I just say right now, if this is a min heap, the smallest value of the min heap would be the kth largest element. Would you agree with me on this? The root of the min heap is the kth largest element.
Yes.
The top four largest element are put into the min heap. Whatever is the smallest is the kth largest element because I have maintained the overall min heap of size k. Is it that? Agreeing with me on this? Agreeing with me on this? Okay, so this is an array of values. What I am required to do is till the time the priority queue is fully filled, till its size is not equal to that of 4, I would keep on putting the elements right into the min heap, to the priority queue in terms of min heap. Whenever the size has grown equal to that of 4, if the current element of the array that I am exploring, right, is greater than the root of the min heap, remove the root, put the greater element inside the min heap. Then they will rearrange again. Then there would be a rearrangement again, log n operation for rearrangement, not more than that. Correct? Okay. So keep on doing this till the end. At the end, topmost four largest value would be put inside the min heap. Whatever is the root, that would be the kth largest element.
আচ্ছা স্যার,
Yes.
বলছি ভাবুন আমাদের এখানে বের করতে বলতো মানে মিনিমাম এলিমেন্ট, তাহলে মিনিমাম এলিমেন্ট আর কে দিয়ে দিত, ভ্যালু দিয়ে দিত, তাহলে আমরা ম্যাক্স ইউজ করে চারটে করতাম, তাই তো?
Kth, a minimum element, if they would have said, I would have just utilized max heap, and the rest the approach is correct. Approach would be a little bit similar. Okay, just your heap would be changing to max heap. Kth smallest, keep the top k small values inside the max heap. Whatever is the largest, whatever is the root of the max heap at the end, that would be your answer. Okay. Just the reverse. Aniket told well. So how would you code it, by the way, here? Tell me. What I am required to keep? What I am required to declare? Min heap, if I'm not wrong, is it? Min heap is the requirement. So let's declare that within our code. Then what else you are gonna do? What else you are gonna do? For INTI that has gone, that starts off from 0, I less than nums dot size, I plus plus. What you are gonna do next? Tell. All the elements of the array have to explore, right? If PQ dot size, it is lesser than, it's what? It is lesser than K, then what you are gonna do in that case?
ইনসার্ট করতে হবে সব।
PQ dot push nums of I. Straightforward, just push it. Am I correct? Okay, then what else? If it is not lesser, then what you are gonna do?
কম্পেয়ার করতে হবে রুটের সাথে।
If nums of I is greater than PQ dot what?
টপ।
PQ dot top. If it is greater, then you are gonna do what?
PQ dot top equals to nums of I.
PQ dot pop. Straight away I'm gonna pop it, and I would be saying PQ dot push nums of I. That's it. Nothing else is required, I feel. Nothing else is required. Okay. At the end, you have to just return. After doing all the operations, I can just say that return PQ dot top at the end. That's whatever is the kth or largest value. Try running this. Hopefully, this should be working well. Then try submitting. Is it all accepted? Any problem corresponding to the approach? Any problem?
ক্লিয়ার।
What is the time complexity?
n log n।
What's the time complexity? The priority queue is fixed with size k. Am I correct? Priority queue is fixed with size k, not more than k. I can allow the size here. If the size of the priority queue is k, any of the deletion, insertion, and reshuffling of the queue does not take more than log k operations. All of you agree? EP5, if you are just deleting the root, you are just deleting the root. If the root has been affected and then heapification is taking place, it does not take more than log k operations. How many times at max log k operation I may do? Roughly n times. So n log k would be the time complexity. An extra space of k I am utilizing for the sake of priority queue of size k. So big O of k would be your space complexity as well. Works. Is the time and space part clear for everyone?
Yes.
Okay, let's move on to few more problems. Let's see that what other problems we are having. What problems है कहाँ पर? there are not much values to be much things to be taken right now. Okay, so let's see this kth largest element inside a stream. How would you approach the problem, by the way? Kth largest element in a stream. Now there is no fixed array, but you have to consider a kth largest element into a stream of values. How would you do it? How would you do it? So they have asked you find the kth largest from this function, and there is an add function what you need to implement. Tell me, what should I do here? What the question is all about? Okay, I'm giving this problem, right? This goes into the similar lines. Whatever we have solved the previous problem, this problem goes into the similar lines only. I'm giving this as an assignment. First, try that on your own. Then we can discuss that in the next class. Works?
Yes.
Works for everyone. This is on the similar lines you have to solve. Nothing else. And this is also an easier part, easier problem for us. There are, apart from the kth largest and all, there are not much problems with your heap. Heap sort, all the standard ones are there. Only one thing is there that we are required to say is median from a data stream, suppose. You have to find a median for a data stream. Let's see this. So this is a lead code hard problem. Find median of a data stream. For example, array is 2, 3, 4 and the median here is 3, correct? And array is 2, 3, then the median is 2 plus 3 divided by 2, 2.5, correct? So median finder and add num, this is what you are required to add the integer num from the data stream to the data structure and find median. Returns the median of all elements so far. The array should be within 10 to the power minus 5 of actual number. Okay, fine, that's fine. I don't think any problem here should be there. Median, they return the value in terms of, okay, this is the constructor for us, by the way. How they're actually expecting us to find it. And double median, find the median, you have to implement that, by the way. Okay. Now let me know that how you're going to solve this. What would be your approach to solve it? Tell me that. A stream of values would be coming to you. Whenever the add number function would be called, consider that this number would be passed on to the stream of values. What you're going to do in that case? The middlemost two value I am requiring. Am I correct? Middlemost two value. How do you calculate medians? You have to consider the middlemost two values, right? If there are even number of values so far, there are even values 1, 2, 3, 4. The middlemost two values would be part of my median. It would be 2 plus 3 divided by 2, 2.5 would be my answer, right? 2.5 would be my answer, correct? And then what? If there are odd number of values 1, 2, and 3, correct? 1, 2, and 3. Then the middlemost value, whatever I'm having, that would be the median itself. Tell me, how would you approach this problem? What would be your take? What would be your take for this problem? Let me know. What we are requiring actually? What we are requiring actually? Tell me that. What we are requiring? If suppose right now the stream of values has the following things 5, 2, 4, 9, 6, 3, 7. So actually I'm required to convert that to a sorted order array, right? If I wish to have the median of the entire array, I require to convert them to a sorted order array, right? So it's gonna be 2, 3, 4, 5, 6, 7, 9. And what is the size overall? 1, 2, 3, 4, 5, 6, 7. 7. So this 5 would be the median for us. See, right now, if the stream is having odd number of values, right, then straight away return the middlemost value, whatever we are going to have. Whatever we are going to have. Correct? And if it is having, if suppose there would have been another 10, then 5 plus 6 divided by 2, I straight away would have returned this. Okay. So what is the exact number of things I require? You tell me, as per your analysis, if repeatedly, right, repeatedly I cannot contain a very big array where I'm going to be adding the values continuously. And I have to sort it again and again. A repeated amount of sorting I have to do whenever there is a median calculation that would be required. And afterwards, I can just say, grab the middlemost two values or middlemost value and return that. Repeated sorting. For each sorting, I would be requiring at least n log n time complexity. That I cannot afford. If there are q queries, suppose, then corresponding to q queries of median calculation, n log n operation would be performed each. And based on that, then the final median would be returned. Okay, not a very efficient one. How many queries in total would be there? Let me just see here, right? So at most 5 into 10 to the power 4 false would be there, right? So I can just try assuming that 5 into 10 to the power 4 queries, each for finding median is there, let us suppose. Or let's suppose that half of them are add median, add num, half of them are find median, right? Divided by 2. These are the number of function calls to find median would be there. Corresponding to each and every one of them, there is a n log n operation that I'm going to perform. So overall the num, or these are the value of num, I feel, right? These are the value of num. So see, corresponding to add number, let's say half of them are add number. A new number has got added with each add number operation. So I can just say if add number is how many add number at max I can try assuming. If I keep a balance, it could be 5 into 10 to the power 4 divided by 2 into some log value of this, log of the current value. So this is coming approximately 25 divided by 4 into 10 to the power 8. That's greater than 10 to the power 8, right? Not a very efficient approach we are taking here in order to calculate the median. Then what should I do? What are your thoughts? What should I do? What should I do? As per you, what should I do? Tell me. What should I do as per you? Let me know. Any ideas? See for here, what are the things I require in order to calculate the median, right? In order to calculate the median, what I require is half of the values, right? Both the halves I require to separate out. I feel the first half's greatest value I require, the second half's smallest value I require. Is it what are my requirements? So can I just say the smallest n by 2 values, right? Its greater value I require. I can maintain that in terms of a max heap. Can I just say this? What are the smallest set of n by 2 values maintained in terms of a max heap? And the largest n by 2 remaining values, whatever I'm having, maintain that in terms of min heap. Can I just say that? Agree with me on this, all of you? Agree with me on this or not? Please tell.
Yes.
This is how I may try arranging the values, right? If the overall, now what I'm going to be doing is, if the overall number so far, after performing the last add query, if the so far size of the array or the numbers, what we are considering the size of both the heaps has gone up till a even number. The roots of both of them I would be fetching up, big O of one time, and add them and divide it by 2, return the value. Root 1 plus root 2 divided by val. That's what I'm gonna return. Okay. If it is an odd number for us, right? If it is an odd number. So whatever would be the root of the max heap, the first half, that would be my answer. I would be just returning this. Works for everyone? First tell me that. Works for everyone? Can we try having the intuition something like this? Let us try with this value, right? One by one, if these are the set of values that we are considering, right? How we would just arrange the priority queues. Okay, let's say that the add number queries are 5. These are the add number queries. Add 5, then add 9, correct? Add 5, then add 9, correct? And then what should we do? Tell me. Then afterwards, let there be another add operation. Let there be 4. correct so far, and then call for the median calculation. Now suppose that I am having two values. One is the min heap, one is the max heap. Right? First set of smaller than by 2 elements, I wish to keep them inside a max heap. And second one would be a min heap, right? Second one would be a min heap. Size so far is 0 for us, right? Overall size of elements is 0 for us. First query is coming in terms of 5. What you are going to do in that case? First query is coming in terms of 5. I would say that, okay, since there are no elements, whatever is the new element coming, put that into the min heap, max heap, right? Works. Put that into the max heap. Then add 9. Then add 9 is coming into the picture. What you are going to do in that case?
Min heap.
Okay, just this 9 is there, right? This is the greatest value so far I am considering. Greatest value. Put that into the min heap. Done. Put that into the min heap. Then again, 4 is coming into the picture. 4. So far, smallest value, whatever we are getting, the smallest value. Then what you are going to do in that case? I can just put that into the max heap, right? Smallest two values are part of my max heap, and min heap has the largest value so far, right? This max heap can have one element extra whenever the overall size is going to be odd. So far, the size is 3. So I can just say one element extra I can keep into the max heap. And right now, the median calculation has come up. Overall size is odd. Whatever is the root of the max heap, just return that. So for this, 5 is coming as my answer. That's fine, I feel. Overall, as per these three queries, 4, 5, and 9. If you sort them, 5 is going to be the median, right? Okay. Next, let's consider more queries, right? As per our array values, whatever we have taken. 9, 6, 3, and 7. So let us suppose I say add 9 and add 6. Okay, sorry. We are changing the values. Let that be add 2. We have skipped the value 2, suppose. Okay. We have skipped the value 2 and 2 afterwards. Let's add 6. Okay, now add 2. What you are going to do in that case? Whenever I would be adding 2, size should be going equal to that of 4. As per this query, size should be going up to that of 4. So I think 2 should be there into the max heap, 2 should be there into the min heap, if I'm not wrong, right? That's how the arrangement should be. N by 2 smaller would be as a part of max heap, N by 2 larger would be part of min heap. Tell me, then what should happen? Add 2, you are going to do. Smallest two values of the overall stream so far should be part of max heap. Whatever is the root of the max heap, that's greater right now for us. I would just pop it out. This can no longer be a part of max heap because the current value is smaller than this. Just pop it out, put that into the min heap. Largest two values would be part of min heap and 2 would be going inside the max heap. All fine. 2 would be going inside the max heap. Then add 6 is coming into the picture. Right now, the value would be turned out to be odd. The overall size of the stream numbers are going to be odd for us. Then what you are going to do here? Tell. What you are going to do here? Tell. 6. 6 is coming into the picture. Where I can keep it?
Min heap.
Exactly. Min heap. I have to put that into min heap, right? 6 is there. But right now the value is 5. Why can't I keep that into the max heap? Anyhow, I can try keeping that into the max heap. What are your thoughts? So I can just say that if the value is odd, right? Value is odd. We can, okay, fine. So let's take the analogy by the way that one lesser element can be there into the part of max heap and one more element, whatever the redundant element I am having into. But as per the analogy, whatever we are going, right? The root of the max heap only should be, if there are odd number of elements into the stream, root of the max heap only should be my answer as a part of the median. That's what we have also considered previously as well. Now, in this case, what you are going to do? Right now, the overall size is going to be odd for us. After 6 would be pushed, overall size would be changed to 5 of the given stream of numbers. What you are going to do in that case? Can I just say, see, largest two numbers should be part of the min heap. So whatever is the min heap for me right now, its smallest element 6 is greater than that. So I would just pop it out, put that back into the max heap. Can I do it? Can I do it? And then 6, put that into the min heap. Largest two elements part of the min heap, smallest 3 elements part of the max heap. One extra can reside into the max heap, right? And if somebody asks you that calculate the median right now, straight away, since there are odd number of elements, whatever is the maximum element of the max heap, just print it 5. Works? Works or not? What are the remaining elements? We are having 3 and 7 suppose. So now somebody is asking you add 3, then print the median. Add 3, then print the median, right? And then add 7, and then again print the median. This is how the query is looking like. What you are going to do corresponding to these two queries? Tell me that. What you are going to do here? Tell me. Add 3 and then print the median. What you are going to do? Right now the size would be, after add 3, size would be equal to that of 6 for us, right? Size would be equal to that of 6. What you are going to do? 3 is smaller than the largest value of the max heap. Pop it out, put that into the min heap. 3 is put into the max heap for me right now. Smallest 3 into the max, largest 3 into the min heap. Works. Working completely fine. I don't think any problem is there. Is it that? Right? And then they have asked you, grab the median. So largest of the max heap, smallest of the min heap. 4 plus 5 divided by 2. 9, 4.5 would be the answer. Is it? Then add 7 is there. Add 7 is there. What you are going to do in that case? Add 7. Add 7. At 7, right? This is the 4, 4, 2, and 3. All smallest 3 elements are there into the max heap. This 7 is greater than the, since right now the elements are going up to odd number of values. 7, total of 7 elements are there into my stream so far after addition of 7. What will happen right now? Tell me. What will happen right? This 7 is greater than, so 4 elements can be here. 4 elements can be here. 3 elements I would keep into the min heap. Since 7 is greater than the minimum of the min heap, put that back into the max heap. Put the element 7 into the min heap. And after that median calculation, whatever is the maximum of your max heap, just print it. Is it coming well? If I consider all the elements of the stream, the sorted order should be 2, 3, 4, 5, 6, 7, 9, right? 5 is the median. We are getting it absolutely correct. Any problem? Any problem? Any problem with the analogy, how to play up with 2 heaps? Let me know on this. Any problems?
Clear.
Is it clear how to play up with around? Can you try coding it or should I be doing for you? Can you try coding it or should I be doing it for you? Median finder. So here what I'm going to do, let me just initialize 2 priority queues, right? You may or may not fill it. Should I be filling it, by the way? The last, what they have asked me is, explanation is this. How do you optimize your solution? There would be at least one element. Okay, before calling the find median value, right? Median finder, what should I do here, by the way? I don't think anything is worthy enough to be done here. Let me just say that let there be priority queues, right? That's what I need to declare, 2 priority queues. So let me just do it. 1 for the min, 1 for the max. Everything I would be declaring inside, suppose. Okay, max heap also declared, min heap also declared, right? This, both of the things I have done. Then what you are required to do next? And let there be a initially size for me, right? Size. And I say that, okay, do one thing inside the constructor, just initialize the size to be 0. We can do it. If something has to be done, let's do it by. Anything else we are required to do? Okay, add number, suppose. Add number. You are performing the add number operation. I would say that size plus plus 1 number gets added to the stream for us. 1 number gets added to the stream. Then what cases should I be covering here? Let me know on this. Let me know that what cases should I be considering here.
Sir, এই যে দুটো মিনি ম্যাক্স হিপের সাইজটা দেখতে হবে।
A few things. If size is what? Size is
Odd or
what?
even.
Size is odd, suppose. Size divided by 2 equal to that of 0. If it is even, if it is odd, then 2 different operations I am required to perform. What are the operations for us, by the way? Tell me. What are the operations for us? Tell me.
স্যার প্রথম দুটো টপের বাই 2 হবে প্লাস 4 বাই।
Okay, if it is even, by the way. If it is even, then one of the cases what? If it is even, right? Right now it is going for an even case for us. So there are 2 heaps. One is max, one is min. Correct. The element X needs to be inserted into the stream. Okay. Now, what are the things? X is smaller than, for me, X is smaller than the largest value of the max heap. Then what you are going to do? First case, whatever element X is going inside, if num is smaller than max heap name, okay, I'm sorry, PQ1 and 2, that's what we need to consider, right? Let's say the min heap is PQ2 and max heap is PQ1 for us. Right? Okay. If num is smaller than PQ dot top, PQ1 dot top, max heap part, then what you are going to do? Num is smaller than PQ1 dot top, then what you are going to do? What you are going to do? Can I just say int m would be equal to PQ dot top? And I can just say it's not PQ, but PQ1. PQ1 dot pop it out. And PQ1 dot push the number num, right? Maximum value of the max heap is smaller than the current value. Current value would be going inside the max heap, correct? Smallest values would be residing into the max heap. And the number m, maximum max heap, whatever we are having, that would be moved on to the min heap. One such case, right? Okay. If this is so, and then I would be saying that PQ1 dot push what? PQ1 dot push, what will happen? PQ1 dot push, sorry, PQ2 dot push it would be, right? PQ2 dot push, what will happen here? Tell me.
M.
Yeah, that's it. Okay, if it is not the case, the value X is not smaller than the maximum of the max heap, then what you are going to do? Value X, whatever I got, it is not smaller than the maximum of the max heap. It's greater than that. Then what I can do in that case? Value, whatever is the maximum of the max heap I have maintained so far, right? Value X is greater than that. Then what you are going to do? Straight away push that into the min heap. Can I do it? It belongs to the larger half. Can I straight away push that? Else. No need to do any kind of pop operation and all. Just say that PQ2 dot push the value of num. Will that work in our case? Will that work in our case? This is for the sake of whenever the size is going even. Whenever the size is going even, right? This is the case. Anything else that we need to consider? Anything else we need to consider, right? Anyhow, prior to the current element, everything was odd. Everything was odd, right? Everything was odd. Okay, any kind of rearrangement from the min heap we are required to do? I don't think so, if I'm not wrong. I don't think so. Any kind of edge cases that you can consider? Suppose that 1 to 4 are the initial values here. The coming element is 5. And another value, 4, 5 is also here. If I, 4, 6 is also there, right? 4, 6 is also there. If I put 5 into the min heap, that does not cause any harm, I feel, right? The current value is greater than the maximum of the max heap, the first half. Straight away put the value into the min heap. Works? Works, yes. Right? No problem at all. Okay, this part is done. Now the part of odd value is coming into the picture. Else, this part is done, I feel, right? Size mod 2 equal to 0, that's fine. Else, size is the value right now. Whatever will get added, that would be a order value, odd value for me. Then what I'm going to do in that case? What I should be doing in that case? Tell. Min heap max heap consideration again. Min heap max heap consideration again. Min max. Sorry, this is max and this is min. What you are going to do in that case? X is coming into the picture. X is coming into the picture. X is straight away smaller than the maximum of the max heap. Right now, odd value would be happening. Is there. Suppose that X equal to 3. 1 to 4 are the values here. Here 5, 6 are the values. Correct? Into the min heap. Then X is whatever is the value of X that is getting inserted, that is smaller than the maximum of the max value. Straight away I can put that into the max heap. Will it be possible? Will it be possible? if your num, whatever you're considering, it is smaller than pq1 dot top, if I'm not wrong, right? Straight away just say pq1 dot push. pq1 dot push what? What will happen? pq1 dot push what? What should happen here? Tell me.
Num.
Then else, if it is not the case, then what you are gonna do? X is greater than again the max value of the max heap. Then what you are gonna do? X is greater than the max value of the max heap. Then what you are gonna do?
Push it into main.
Okay, if it is equal to that of what should I say? Let there be 3 here in this case, and 4 is going to be inserted. Then what you are gonna do in that case?
Push it into main heap.
So I feel, see, if you are trying to maintain, okay, sorry, my analogy is correct, very bad here. I'm sorry for this. Let there be 5, 6, 7 here, right? 5, 6, 7 here. Smallest here maintained, largest here also maintained. So what's the exact condition we are getting here? What's the exact condition we are getting here? That it's not gonna be pq1 dot top, but it should be pq2 dot top. If from the minimum of the min heap, the current value is smaller, straight away put that into the first heap. Correct? First heap, right? Else, if the current value is not smaller than the minimum of the min heap, current value x is not smaller than the minimum of the min heap, then what I'm required to do? Right now, whatever is the value you got 4, it is smaller than the minimum value of the min heap, the writer half. Then I say that, okay, 4 belongs to the max heap, put that as it is. Else, what I'm required to do? Suppose that you are trying to insert 6, another 6. And this 6 is not actually smaller than the minimum of the min heap. Grab this min heap, put that back into the max heap. 5 would be here. And then after popping it out, I can put 6. Will it work? Will it work? So I can just say let m be equal to that of pq2 dot top, and then pq2 dot pop it would be, right? pq2 dot pop, pq2 dot push the value of num, and I have to say that pq1 dot push the value of n. That's it you are required to do. Am I correct? That's how the overall rearrangement should be looking like, if I am not wrong, as per our analogy. Correct? All fine? Okay, double find the median. What's gonna happen here? If the size is size mod 2 equal to 0, one case is that you are having a even size, there are even number of elements into the stream, there are odd number of elements into the stream. Let there be a double answer. Let there be a double answer. Then what you are gonna do in this case? Tell me. So let me just say double D1 would be equal to that of your okay, if this is the case, I don't require any else condition, by the way. Double D1. How to calculate the median? Double D1, let me try accessing the value of PQ1 dot top. And let there be double D2. Let this be equal to that of PQ2 dot top for me. Correct? And if there are even size for me, then what I'm required to do? Answer return what? T1 plus D2 divided by 2 works. Straight away just divide and return. Works? Works or not, let me know. Else if this is not the case, then I can straight away say answer would be equal to that of your PQ1 dot top, the extra element of the max heap that we are maintaining, and just straight away return that. Okay, that's what is the scenario. That's how it's gonna look like. I don't think any more scenes should be there. What are your thoughts? Any kind of corner or edge cases that we are left off with? Any kind of corner or edge cases that we are left off with? Let me try running this. Let's see whether we are able to do it or not. Time error binding to where is it, by the way? 16. Constantly where? Yeah, might be some in some particular edge cases it has gone wrong. Okay, consider the case. Suppose, what is happening is for the first time the element is going inside the priority queue. Should this condition be executed? Should this condition be executed here? Let me know. So what I'm trying is that if the size is straight away, you just say that if size is equal to that of 1, but the first value it's going inside, then I can just say pq1 dot push the value num and straight away from here return, right? Do nothing. No particular comparison and all is required in this particular case. We can just put the element into the, okay, so it is getting accepted. That was the corner case that we missed out, right? For the first time, whenever for size equal to 1, the number would be going inside the priority queue or would be counted as a string. If you try checking for the pq dot top, right, this situation, you're gonna get some null error, null pointer error, that when there is nothing into the priority queue 2, how can you check for the top, right? How can you check for the? Try submitting this. Let's see whether we got any kind of acceptance or not. Yes, we got it. Any problem? Any problem how to play up with 2 priority queues? Let me know. Median of a stream of values. Any problems? Quite delicately, we have handled the entire case, if I am not wrong. Any problem you people are having? Any problem? Any problem? So for each query, right, each of the add or subtract, each of the addition query, whenever you are adding a particular value to the heap, whenever you are performing the addition operation, right, I am just transferring some of the values from the min heap to the max heap either, or from the max heap to the min heap either, right? So there would be at max of 2 log n by 2 log n by 2 operations for each heapify. You take the top of here, transfer that to the previously available to the next available heap. You take the top of here, transfer that to the another heap, whatever we are maintaining. So both of them can get heapified simultaneously, log n by 2 log n by 2. This is what I am concerned about right now. Nothing else. Correct? 2 log n operation approximately I perform for each at num query. And in case of your median query, I do nothing, but I just grab their top values, top of both the heaps I grab, and I do some calculation, I return. So this is the big O of 1 operation for me. So with the help of max heaps and min heaps, I have just managed to solve the entire question in log n time per query. Log n time per query. Okay, per query, there's going to be no more than log n operations. What's the space complexity? I'm preferring, so log n, sorry, it's nn, n by 2 for each of the priority queue. So basically, big O of n, space complexity, I utilize to solve the overall problem. Okay, any doubts? Any doubts for the priority queue part? Let me know on this. Any doubts? Median we have seen already. Anything else you required? Tell me. Any particular doubts you people have? Any doubts anyone is having? Tell me. So see this. You can try the same problems on the similar line. Sliding window median. For a window of fixed size. For a window of fixed size, you have to grab the median. You have to grab the median. Correct? You have to grab the median. So in whatever manner I have already solved it, you can try solving this question in a similar manner. Right now, we were handling the case for the sake of for per query basis, right? Any number of values can be there into the stream. But I feel right now you have to deal with only size k operation. Only for the sake of a fixed size window, you have to grab the median elements. So this is gonna be your assignment. You will do it and you will bring the solution the next day. Okay, any more doubts? Let me know.
Okay.
Okay, this problem, please do it.